Hi, my name's Simon Green, I work for Juniper Networks. So in this multi-part series we'll be looking at adding Contrail SDN as the CNI for Amazon's EKS. This is Amazon's managed Kubernetes cluster. So in the first part of this series I'll be using Amazon's quickstart to deploy the EKS cluster on worker nodes, but I'll be making some small modifications to the cluster stacks so that the worker nodes are running on Ubuntu Linux. So this is needed because by default the Contrail vrouters are compiled for CentOS, Red Hat Linux and for Ubuntu Linux. We could of course go through recompiling the vrouters for AWS Linux, but just to keep it simple, it's easier to switch the worker nodes than it is to switch the vrouter. So this video is going to focus on AWS quickstart and the modifications and deploying an EKS cluster. It'll be production-like, so multi-node. The second video is going to add Contrail SDN as a CNI. So this first video is a little tricky technically, so apologies for that. And you'll certainly need some background in DevOps in order to follow it. But I will be providing the scripts and patches that are shown throughout at the end of the video, so there's no need to make notes. So there are many ways to deploy EKS within AWS. My firm favorite is to use the quickstart stacks that AWS kindly provide on GitHub. Our target architecture will be one VPC, 3 availability zones. We'll be deploying an AWS EKS master off somewhere inside AWS. So it's an HA master and really to us just looks like an API endpoint. We'll have public-private subnets, so each AZ will have a NAT gateway so that the minions can punch out to internet. There's also a Bastion host. It's shown a little unusually in this diagram, but it's a single instance that bridges the public-private subnets in order to get access to the cluster. So the only instance within the stack that's connecting to the public subnet is the Bastion host, and this is the way that we like it. So I'm running this from my Mac, but you could also do it from a Linux host. So let's take a look at the files that I'll be using throughout. So there's not much here, and I'll be sharing these at the end of the video series. But essentially we have some patches, we'll talk about those shortly. We have a script to deploy the CNI, we'll be using this in the second video. We have a CNI.yaml, which is used for deploying Contrail on top of Kubernetes. And we have a script to make the bucket and place quickstart inside it within your Amazon account. So the first thing to do is to clone the quickstart for Amazon EKS. This is going to take a few minutes. It's around half a meg, so we're going to cut back to the video when it's complete. So our git clone is finished and it's added a new directory, quickstart Amazon EKS. And if we take a quick look, you can see that this git contains CloudFormation stacks, Lambda scripts and configuration files in order to run in a very simple way a production EKS cluster in your AWS account. So the quickstart stacks by default don't support Ubuntu worker nodes. However, Ubuntu do already compile worker nodes as AMIs inside Amazon. So it's really just a case of tweaking the quickstarts in order to get those Ubuntu worker nodes up and running so that we can then deploy vrouters within them when we add Contrail as the CNI. So I've provided 4 patches. They're very straightforward. So patch 1 is adding some additional IAM roles to the worker nodes, and this is because the Ubuntu AMIs are using a later version of CFN init. CFN init is the program that joins an EC2 to AWS. Patch 2 is simply adding a new option in one of the drop-downs in the GUI for Ubuntu EKS worker nodes. Patch 3 does the grunt of the work. So it's adding a new option for Ubuntu EKS worker nodes. It's then providing the AMIs per region for those worker nodes so that the stack doesn't just work in the region that I show you in the video. And then it's adding a block of cloud init code that gets run as the instances come up. And what that code does is it prepares the AMI, fixes a couple of bugs that I found en route, and does some of the grunt work that's missed, setting a time zone, configuring NTP, configuring the host name correctly, and then it just goes on to run the standard easy install script that AWS themselves use to configure their own worker nodes. And patch 4 is just another place where we're adding an option for Ubuntu. So if you're interested in how Ubuntu build those EKS worker nodes, or if you're thinking of building your own private OS, then AWS Labs kindly provide a GitHub which includes the Packer scripts that build these nodes. So in this case, Canonical have already done the work and they've provided a list of AMIs for each region, and we'll be deploying on Kubernetes 1.14. Okay, so let's apply our patches. Patch 1, patch 2, patch 3, patch 4. So next up, we want to push our patched code up into an S3 bucket so we can deploy. So I have a little helper script for that called make S3 bucket. There's a variable at the top that includes the name of the bucket, but I'm going to postpend it with a random string. So you can just leave it, or you can change it to something else. It's up to you. So it's asking me if I have admin rights to the account. So it's going to create S3 buckets, so it needs permission to do that, and yes I do. It's then going to create the bucket for us and push the code up. So it can take a few minutes to run. This script will also deal with diffs. So if you change the code later and run the script again, it will tell you which quickstart S3 buckets you have in your account. And then it will just push up the deltas if you tell it to do that. So another important note is the region you push the S3 bucket into is important. There are bugs around the types of encryption that are supported in S3 buckets. The older buckets support all encryption types, the newer buckets only support the latest. So you'll hit problems if you try to change the S3 region. Okay, so the script's finished, and you can see the last thing it does is it tells you the S3 bucket name that it's created in your account. You see the random string at the end. So in the next step, I'm going to use a quickstart URL to launch the stack. That's one of the beauties of these quick starts, is you just point your browser and off you go. You will have to change that quickstart URL to use the name that the script created when it generated the bucket. I'm going to put that URL in a QR code at the end, so there's no need to take notes. Okay, so that's our launch URL. I've already logged into the account, so it's going to take me to a CloudFormation Create Stack page that points to the first stack in the quick start. So we'll go next. So there's a number of parameters and we will have to set a few, so let's go through it. So select all 3 regions because we're doing an HA deployment. It needs to know the IP address that you're going to connect to the Bastion from. This can obviously be changed later on. It's going to ask you which keys to use on these instances. So I already have an SSH, an EC2 SSH key called Contrail key. I'll reuse that one. For the instance type, so the first 3 worker nodes are going to act as the SDN controllers. You know, if you're doing a small lab, you could also use them to play around with your pods. But in this case, we're targeting production. So just basically following the guidelines for a deployment of an SDN controller, we're going to change the node types to M4 2 times large. Number of nodes, we'll leave it at 3 for now. We're just going to create the controllers and then we'll come back and I'll show you how to add more worker nodes later on in the video. So size of disk, so again following Contrail guidelines, 300 for the disk size. We're going to go with the latest 1.14 on EKS. Now this is the patch that we added. You see in the drop down we have a new selection, Ubuntu EKS. So we're going to select that. And then right down the bottom here it says which S3 bucket name should we be using for the configuration. Well, we've patched it and we've created our own bucket, so we're going to delete that one and we're going to go and get our new bucket. And if you remember, it tells us the bucket name at the bottom. Okay, that's it. So now we can deploy the stack. At the bottom of the review, you're going to see two tick boxes. Tick them both. This is because the stack's going to make changes to IAM, so it needs permission to do that. And then create stack. So this will create a group of nested stacks doing all the heavy lifting for you. And then what you'll be left with is a running EKS cluster with 3 worker nodes. So the stack deploy takes something like 25 minutes. So I'll cut the video and show you when it's finished. Our stack's deployed, as you can see. So this is the first stack, the one that we pointed to and gave the parameters to. In fact, if you look at the parameters, you can see them here. And then these are all nested stacks that get called to build the control plane and build the minions. You can see, as expected, 3 worker nodes, 1 in each AZ, and a bastion. If we take a look at the management node, there you go, we've got a cluster, and the cluster has an endpoint, an API, in order to talk to it. So we're good to go. So the next thing is to connect to it using kubectl. So the bastion's pre-configured for you, so we could SSH up to the bastion, and then from there we could run our kubectl commands. I prefer to work locally on the client. So I'm working on a Mac, and that means that I need to register my Mac onto the cluster. It uses an unusual method of authentication. It's something like a mixture between IAM plus the usual way of accessing a Kubernetes cluster. So I'm really just following the instructions AWS have for connecting your Mac to EKS, and first of all it tells you to install AWS IAM authentication. So I'm already connected to my AWS account, so I just need to request an identity. And then I need to update my local configuration using the ID of the EKS cluster that we just saw in the console. So at this point, we can query our nodes as if we're sitting in the cluster itself. And as expected, I have 3 worker nodes. And we can look at our pods. And we can see we're running some pods, system pods, kubeproxy, CordANS. We're basically up, waiting and ready to go. That's the end of this video. So in the next video in the series, we're going to replace the AWS CNI with Juniper's Contrail CNI.